Hello everyone. If you are preparing for AWS certification, either AWS Cloud Practitioner or AWS Solution Architect exam, then this video series going to help you too much as in this AWS Certification Capsule series, where we will go through as many questions as possible along with their explanation. So it will help you to learn and prepare for your exam. This is part 2 of the series, and I hope this video will help you for your exam. So, let's start. Let's talk about this question. Which of the following describes unused EC2 instances matching a particular set of launch specifications? Options we have: A. Request type, B. Spot instance interruption, C. Spot fleet, D. Spot instance pool. Correct answer for this question is option D. Spot instance pool. Because a spot instance pool is made up of unused EC2 instances. There are 3 request types: request, and maintain, and reserve for duration. A spot instance interruption occurs when the spot price rises above your maximum. A spot fleet is a group of spot instances launched together. Let's talk about next question. Which of the following classes will usually make the most sense for long-term storage when included within a sequence of lifecycle rules? Options we have: A. Glacier, B. Reduced redundancy, C. S3 one zone ya, D. S3 standard ya. Correct answer for this question is option A. Glacier. Because Glacier offers the least expensive and most highly resilient storage within the AWS ecosystem. Reduced redundancy is not resilient and, in any case, is no longer recommended. S3 one zone and S3 standard are relatively expensive. Let's talk about next question. Which deployment type requires an elastic load balancer? Options we have: A. In-place instance deployment, B. Blue or green instance deployment, C. Blue or green Lambda deployment, D. In-place Lambda deployment. Correct answer for this question is option B. Blue or green instance deployment. Because a blue or green instance deployment requires an elastic load balancer in order to direct traffic to the replacement instances. An in-place instance deployment can use an ELB but doesn't require it. A blue or green Lambda deployment doesn't use an ELB because ELB is for routing traffic to instances. There's no such thing as an in-place Lambda deployment. Let's talk about next question. You know that you need 24 CPUs for your production server. You also know that your compute capacity is going to remain fixed until next year, so you need to keep the production server up and running during that time. What pricing option would you go with? Options we have: A. Choose the spot instance. B. Choose the on-demand instance. C. Choose the 3-year reserved instance. D. Choose the 1-year reserved instance. Correct answer for this question is option D. Choose the 1-year reserved instance. Because we can't choose a spot instance because the spot instance can be taken away at any time by giving notice. On-demand won't give us the best pricing since we know we will be running the server all the time for the next year. Since we know the computation requirement is only for 1 year, we should not go with a 3-year reserved instance. Rather, we should go for a 1-year reserved instance to get the maximum benefit. Let's talk about next question. Which of the following occurs when you restore a failed database instance from a snapshot? Options we have: A. RDS restores the snapshot to a new instance. B. RDS restores the snapshot to the failed instance. C. RDS restores only the individual databases to a new instance. D. RDS deletes the snapshot. Correct answer for this question is option A. When we restore from a snapshot, RDS creates a new instance and doesn't make any changes to the failed instance. A snapshot is a copy of the entire instance, not just a copy of the individual databases. RDS does not delete a snapshot after restoring from it. Let's talk about next question. When creating a DynamoDB table, how many read capacity units should you provision to be able to sustain strongly consistent reads of 11 kilobytes per second? Options we have: A. 3, B. 2, C. 1, D. 0. Correct answer for this question is option A. 3. A single strongly consistent read of an item up to 4 kilobytes consumes 1 read capacity unit. Hence, reading 11 kilobytes of data per second using strongly consistent reads would consume 3 read capacity units. Let's talk about next question. Which of the following are possible advantages of hosting a relational database on an EC2 instance over using the RDS service? Choose 2. A. Automated software patches. B. Automated OS updates. C. Out-of-the-box auto-scaling. D. Cost savings. E. Greater host control. Correct answers for this question are option D, cost savings, and option E, greater host control. Because the remaining options, automated patches, out-of-the-box auto-scaling, and automated OS updates, are benefits of a managed service like RDS, not of custom-built EC2-based databases. Let's talk about next question. Your new web application requires multiple EC2 instances running 24/7, and you're going to purchase reserved instances. Which of the following payment options is the most expensive when configuring a reserve instance? Options we have: A. All upfront. B. Partial upfront. C. No upfront. D. Monthly. Correct answer for this question is option C, no upfront. Because no upfront is the most expensive option. The more you pay upfront, the lower the overall cost. There's no option called monthly. Let's talk about next question. How are IAM rules commonly used to ensure secure resource access in relation to EC2 instances? Choose 2. Options we have: A. A role can assign processes running on the EC2 instance itself permission to access other AWS resources. B. A user can be given permission to authenticate as a role and access all associated resources. C. A role can be associated with individual instance-based processes, Linux instances only, giving them permission to access other AWS resources. D. A role can give users and resources permission to access the EC2 instance. Correct answers for this question are option A and option D. Because IAM rules define how resources access other resources. Users cannot authenticate as an instance role, even role can't be associated with an instance's internal system process. Let's talk about next question. You are building a system to distribute confidential training videos to employees. Using CloudFront, what method could be used to serve content that is stored in S3 but not publicly accessible from S3 directly? Options we have: A. Create an origin access identity, OAI, for CloudFront and grant access to the objects in your S3 bucket to that OA. B. Add the CloudFront account security group called Amazon CF/Amazon CF SG to the appropriate S3 bucket policy. C. Create an identity and access management, IAM, user for CloudFront and grant access to the objects in your S3 bucket to that IAM user. D. Create an S3 bucket policy that lists the CloudFront distribution ID as the principal and the target bucket as the Amazon resource name, ARN. Correct answer for this question is option A. Create an OA for CloudFront and grant access to the objects in your S3 bucket to that OA. Let's talk about next question. A solutions architect is designing a 3-tier web application that includes an auto-scaling group of Amazon EC2 instances running behind an ELB classic load balancer. The security team requires that all web servers must be accessible only through the load balancer and that none of the web servers are directly accessible from the internet. How should the architect meet these requirements? Options we have: A. Use a load balancer installed on an Amazon EC2 instance. B. Configure the web server's security group to deny traffic from the public internet. C. Create an Amazon CloudFront distribution in front of the ELB Classic load balancer. D. Configure the web tier security group to allow only traffic from the ELB Classic load balancer. Correct answer for this question is option D. Because security groups only allow you to allow traffic, not deny it, that's why answer B is not possible. Let's talk about next question. A solutions architect is designing a web application that will be hosted on Amazon EC2 instances in a public subnet. The web application uses a MySQL database in a private subnet. The database should be accessible to database administrators. Which of the following options should the architect recommend? Choose 2. Options we have: A. Create a bastion host in a public subnet and use the bastion host to connect to the database. B. Log into the web servers in the public subnet to connect to the database. C. Perform DB maintenance after using SSH to connect to the NAT gateway in a public subnet. D. Create an IPsec VPN tunnel between the customer site and the VPC, and use the VPN tunnel to connect to the database. E. Attach an elastic IP address to the database. Correct answers for this question are option A and option D. Option B is incorrect because we wouldn't hop onto a web server just to access another server in a private subnet. This would be a security vulnerability. Option C is incorrect because NAT gateways allow servers out to the internet but prevent incoming connections from the internet, completely the opposite of what we are trying to achieve in this question. Option E is incorrect because elastic IPs are public, if attached to the database, would invalidate it from being in a private subnet in the first place. Let's talk about next question. A web application running on Amazon EC2 instances writes data synchronously to an Amazon DynamoDB table configured for 60 write capacity units. During normal operation, the application writes 50 kilobytes per second to the tail, but can scale up to 500 kilobytes per second during peak hours. The application is currently throttling errors from the DynamoDB table during peak hours. What is the most cost-efficient change to support the increased traffic with minimal changes to the application? Options we have: A. Use Amazon SQS to manage the write operations to the DynamoDB table. B. Change DynamoDB table configuration to 600 write capacity units. C. Increase the number of Amazon EC2 instances to support the traffic. D. Configure Amazon DynamoDB auto-scaling to handle the extra demand. Correct answer for this question is option D. Because requirement in this question is most cost-efficient change to support the increased traffic with minimal changes to the application. That's why we need to configure Amazon DynamoDB auto-scaling to handle the extra demand, because it is cost-effective, only scale up when needed, and there is no change required to application. Let's talk about next question. One company wants to share the contents of their Amazon S3 bucket with another company. Security requirements mandate that only the other company's AWS accounts have access to the contents of the Amazon S3 bucket. Which Amazon S3 feature will allow secure access to the Amazon S3 bucket? Options we have: A. Bucket policy. B. Object tagging. C. CRS configuration. D. Lifecycle policy. Correct answer for this question is option A. Bucket policy. Because bucket policy helps to configure permissions for all objects within a single S3 bucket. Let's talk about next question. A solutions architect is designing a service that must have 4 Amazon EC2 instances running between 8 a.m. and 6 p.m. daily. The service requires 1 EC2 instance outside of those hours. What is the most cost-effective way to provide enough compute? Options we have: A. Use 1 Amazon EC2 reserved instance and use an auto-scaling group to add and remove EC2 instances based on CPU utilization. B. Use 1 Amazon EC2 on-demand instance and use an auto-scaling group to add and remove EC2 instances based on CPU utilization. C. Use 1 Amazon EC2 on-demand instance and use an auto-scaling group scheduled action to add 3 EC2 spot instances at 7:30 a.m. and remove 3 instances at 6:10 p.m. D. Use 1 Amazon EC2 reserved instance and use an auto-scaling group scheduled action to add 3 EC2 on-demand instances at 7:30 a.m. and remove 3 instances at 6:10 p.m. Correct answer for this question is option D. Use 1 Amazon EC2 reserved instance. We need 1 instance to run 24/7 as per the question. And to provide cost-effective solution, we will use 3 EC2 on-demand instances between 8 a.m. and 6 p.m. daily. Let's talk about next question. A company plans to use an Amazon VPC to deploy a web application consisting of an elastic load balancer, a fleet of web and application servers, and an Amazon RDS MySQL database that should not be accessible from the Internet. The proposed design must be highly available and distributed over 2 availability zones. What would be the most appropriate VPC design for this specific use case? Options we have: A. 2 public subnets for the elastic load balancer, 2 public subnets for the web servers, and 2 public subnets for Amazon RDS. B. 1 public subnet for the elastic load balancer, 2 private subnets for the web servers, and 2 private subnets for Amazon RDS. C. 1 public subnet for the elastic load balancer, 1 public subnet for the web servers, and 1 private subnet for the database. D. 2 public subnets for the elastic load balancer, 2 private subnets for the web servers, and 2 private subnets for RDS. Correct answer for this question is option D. Because, when you add a subnet to your load balancer, elastic load balancing creates a load balancer node in the availability zone. Load balancer nodes accept traffic from clients and forward requests to the healthy registered instances in one or more availability zones. For load balancers in a VPC, we recommend that you add 1 subnet per availability zone for at least 2 availability zones. This improves the availability of your load balancer. Note that you can modify the subnets for your load balancer at any time. Let's talk about next question. A workload in an Amazon VPC consists of a single web server launched from a custom AMI. Session state is stored in a database. How should the solutions architect modify this workload to be both highly available and scalable? Options we have: A. Create a launch configuration with a desired capacity of 2 web servers across multiple availability zones. Create an auto-scaling group with the AMI ID of the web server image. Use Amazon Route 53 latency-based routing to balance traffic across the auto-scaling group. B. Create a launch configuration with the AMI ID of the web server image. Create an auto-scaling group using the newly created launch configuration and a desired capacity of 2 web servers across multiple regions. Use an application load balancer, ALB, to balance traffic across the auto-scaling group. C. Create a launch configuration with the AMI ID of the web server image. Create an auto-scaling group using the newly created launch configuration and a desired capacity of 2 web servers across multiple availability zones. Use an ALB to balance traffic across the auto-scaling group. D. Create a launch configuration with the AMI ID of the web server image. Create an auto-scaling group using the newly created launch configuration and a desired capacity of 2 web servers across multiple availability zones. Use Amazon Route 53 weighted routing to balance traffic across the auto-scaling group. Correct answer for this question is option C. Because, if you host a website on multiple Amazon EC2 instances, you can distribute traffic to your website across the instances by using an elastic load balancing, ELB, load balancer. Let's talk about next question. A solutions architect is developing a new web application on AWS. The services must scale to support an increasing load. The architect wants to focus on software development and deploying new features rather than provisioning or managing servers. Which AWS service is appropriate? Options we have: A. Auto-scaling. B. Elastic Beanstalk. C. EC2 Container Service. D. Cloud Formation. Correct answer for this question is option B. Elastic Beanstalk. Because, AWS Elastic Beanstalk is an easy-to-use service for deploying and scaling web applications. There is no additional charge for Elastic Beanstalk, you pay only for the AWS resources needed to store and run your applications. Let's talk about next question. A company wants to migrate a 3-tier web application to AWS. The company wants to control the placement of the instances and have visibility into underlying sockets and cores for licensing purposes. Which compute model should a solutions architect choose to accomplish this task? Options we have: A. EC2 reserved instances. B. EC2 spot instances. C. EC2 dedicated hosts. D. EC2 placement groups. Correct answer for this question is option C. Because when we need to track usage of our licenses against physical resources such as sockets and cores, and dedicated hosts helps you to do this. Let's talk about next question. An application runs on multiple Amazon EC2 instances. Each running instance of the application must have access to a shared file system. Where should the data be stored? Options we have: A. Amazon S3. B. Amazon DynamoDB. C. Amazon EFS. D. Amazon EBS. Correct answer for this question is option C. Because, when application instance needs to access shared file system, then we need to store data in Amazon EFS. Let's talk about next question. A solutions architect is designing a microservice to process records from Amazon Kinesis streams. The metadata must be stored in Amazon DynamoDB. The microservice must be capable of concurrently processing 10,000 records daily as they arrive in the Kinesis stream. The most scalable way to design the microservice is: options we have: A. As an AWS Lambda function. B. As a process on an Amazon EC2 instance. C. As a Docker container running on Amazon ECS. D. As a Docker container on an EC2 instance. Correct answer for this question is option C. Because Amazon ECS is a highly scalable Docker container management service that allows you to run and manage distributed applications that run in Docker containers. Let's talk about next question. A university is running an internal web application on AWS that students can access from the university network to check their exam results. The web application runs on Amazon EC2 instances and pulls results from an Amazon DynamoDB table. Auto-scaling is currently configured to add a new web server when CPU is greater than 80% for 5 minutes. DynamoDB is configured to increase both read and write capacity units by 5 when utilization is greater than 80%. Exam results are released at 9 a.m. each Monday, and 80% of students attempt to access their unique result within the first 30 minutes. Despite auto-scaling being enabled, students are complaining of slow response times and errors when they view the site. There are no performance complaints after 9:30 a.m. on Monday. Which recommendation should a solutions architect make to improve performance in a cost-effective manner? Options we have: A. Scale out the EC2 instances to ensure that the environment scales up and down based on the highest load. B. Implement Amazon DynamoDB Accelerator to improve database performance, and remove the need to scale the read/write units. C. Use a scheduled job to scale out EC2 before 9 a.m. on Monday and to scale down after 9:30 a.m. D. Use Amazon CloudFront to cache web requests and reduce the load on EC2 and DynamoDB. Correct answer for this question is option C. Because, if the scheduled scaling is performed before 9 a.m. and taken down after 9:30 a.m., this would satisfy the complaints without costing the earth in the process. Let's talk about next question. As part of a migration strategy, a solutions architect needs to analyze workloads that can be optimized for performance and cost. The solutions architect has identified a stateless application that serves static content as a potential candidate to move to the cloud. The solutions architect has the flexibility to choose an identity solution between Facebook, Twitter, and Amazon. Which AWS solution offers flexibility and ease of use, and the least operational overhead for this migration? Options we have: A. Use AWS Identity and Access Management, IAM, for managing identities, and migrate the application to run on Amazon S3, Amazon API Gateway, and AWS Lambda. B. Use a third-party solution for managing identities, and migrate the application to run on Amazon S3, EC2 Spot instances, and Amazon EC2. C. Use Amazon Cognito for managing identities, and migrate the application to run on Amazon S3, Amazon API Gateway, and AWS Lambda. D. Use Amazon Cognito for managing identities, and migrate the application to run on Amazon S3, EC2 Spot instances, and Amazon EC2. Correct answer for this question is option C, because serverless has least operational overhead and CUP can provide federated identities. Let's talk about next question. A company needs to capture all client connection information from its application load balancer every 5 minutes. This data will be used to analyze traffic patterns and troubleshoot the application. How can a solutions architect meet this requirement? Options we have: A. Enable AWS Cloud Trail for the application load balancer. B. Enable access logs on the application load balancer. C. Install CloudWatch agent on the application load balancer. D. Enable CloudWatch metrics on the application load balancer. Correct answer for this question is option B. Access logging is an optional feature of Elastic Load Balancing that is disabled by default. After you enable access logging for your load balancer, Elastic Load Balancing captures the logs and stores them in the Amazon S3 bucket that you specify as compressed files. You can disable access logging at any time. Let's talk about next question. An application runs on EC2 instances behind an Elastic Load Balancing application load balancer. The instances run in an EC2 auto-scaling group across multiple availability zones. The application provides a RESTful interface with both synchronous and asynchronous operations. The asynchronous operations require up to 5 minutes to complete. Although the application must remain available at all times, after business hours, the traffic going to the application is greatly reduced and often results in the auto-scaling group running the minimum number of on-demand instances. What should the solutions architect recommend to optimize the cost of the environment after business hours? Options we have: A. Change the availability zones in which the instances were created to another availability zone in the same region with a lower cost. B. Replace all on-demand instances with spot instances in the auto-scaling group. C. Purchase reserved instances for the minimum number of auto-scaling instances. D. Reduce the number of minimum instances to 0. New requests to the application load balancer create new instances. Correct answer for this question is option C. Because in the question key part is the asynchronous operations require up to 5 minutes to complete. So, you cannot use spot instances for that, since the application doesn't save the state anywhere. So if AWS claims back capacity, with a 2 minutes warning, your async process will terminate in a wrong state. That's why we need to purchase reserved instances for minimum number of auto-scaling instances. Let's talk about next question. A solutions architect is designing a web application for document sharing. The users will upload documents that are then made available to other users. There will be tens of thousands of these documents. What is the most cost-effective storage solution? Options we have: A. Amazon EFS. B. Amazon S3. C. Amazon Glacier. D. Amazon EBS. Correct answer for this question is option B. Amazon S3. Because it is best choice along with cost-effective. Let's talk about next question. A solutions architect was tasked with reviewing several templates that build VPCs and ensuring that they meet specific security requirements. After reviewing the templates, the architect realizes that all of the templates are missing important security best practices. What should the architect do to implement security best practices in an efficient manner? Options we have: A. Use VPC peering to enforce network consistency. B. Restrict users from deploying an AWS CloudFormation template. C. Provide the teams a nested AWS CloudFormation template that builds the VPC correctly. D. Create AWS Identity and Access Management (IAM) policies that enforce the corporate VPC architecture standards. Correct answer for this question is option C. As your infrastructure grows, common patterns can emerge in which you declare the same components in multiple templates. You can separate out these common components and create dedicated templates for them. Then use the resource in your template to reference other templates, creating nested stacks. So, that's it in this video. I hope you like the content and help you for your AWS exam preparation. As it is just part 2 of the series. Stay tuned and subscribe for more upcoming videos. Thank you for watching.